So good morning. My name is Vishnu Agnihotri. I am one of the co-founders of GenWise. So GenWise is an organization that supplements the formal school curriculum by offering specialized courses and programs. So we have a team of experts, both educators as well as people who are experts in their disciplines, be they engineers, writers, scientists, designers, researchers in any discipline. We've been doing in-school programs, residential summer camps, school group tours to Auroville till the pandemic hit us. After that, we've gone online. Fortunately, online has had its positives, and in the online era, we felt that it was easier to have these kind of conversations with like-minded people or people concerned about topics in education. So this is our 20th such conversation in the last 1 year. I'll be sharing a link about GenWise, and you can see our upcoming courses in the summer and so on through this conversation. So let me introduce to you Soumya, who is the moderator for today's conversation, and she will introduce the rest of the panel. So Soumya happens to be a batchmate from college days. We were at IIT Madras together, and she's been a friend since then. Soumya went on to do her master's in engineering. And we'll see later that many of our panel actually started in engineering or physics and made their way to math later, except I think Jayashree perhaps. So Soumya, though she has a master's in engineering from Penn State and worked with some of the software giants for a few years, her heart was in education. She got trained as a Montessorian pretty early, and for the last nearly 20 years, she's been very much in education. She worked for a Montessori school in Bangalore at the elementary level. There are not too many elementary Montessori schools, so a lot of her inspiration and insight in education is derived from the Montessori circles she's been part of. A lot of her work in education is also influenced by her time at Auroville, where she's lived for nearly 5 years with her family, as well as taught at some schools in Auroville, alternative schools. The last 4 years, she's been with GenWise doing all kinds of programs, whether residential programs, online courses, parenting sessions using Montessori principles. So currently, one of her large projects is working with teachers in a leading school, trying to get students from grades 1 to 8 to engage with math in a way that math becomes easier. It's a joyous experience, and it connects to real life as far as possible. So she and Sundaram and a couple of other mentors who are part of GenWise are working on this long-term project. About 5 months of this project are already over, and 2 years are yet to go. So that's the background. So Soumya, I hand it over to you now.
Yeah, thanks, Vishnu. That's a generous introduction. So I'll note that. Yeah, so it's my pleasure actually to moderate this panel of really accomplished math educators. So they have long resumes, and let me see how I can get through it without missing out the key elements. So let me start with Jayashree. Jayashree Subramaniam is a university rank holder in her bachelor's program, and she did her master's in math at IIT Madras. And she's currently pursuing a PhD in math education at Homi Bhabha Center for Science Education. She has worked with students at all levels, from middle school up to undergraduates, for 20 plus years. She was also working with educational initiatives, with assessments, learning modules, teacher support material. That is Jayashree. Sundaram, who absolutely will not be called Mr. Sundaram, is a BTech from IIT Bombay and an MBA from IIM Ahmedabad. And after a 17-year career in corporate world outside India, he came back to move to education. So he has 3 decades of experience in education as a teacher, trainer, principal, and an educational consultant. He retired 7 years ago as a principal of the Reliance School in Jamnagar. He has worked closely with Mr. P.K. Srinivasan, and has in some sense relearned the concepts underlying primary mathematics and ways of teaching it. So he has conducted many workshops for teachers across the country. And he has also just written a book for putting these concepts together. Um, our third panelist, Mick Purcell, has his bachelor's in engineering physics from West Virginia and master's in physics from UT Austin. And he is a well-known figure in the IB circles in India. He's been a mathematics teacher for more than 35 years. He doesn't look that old. He's also taught physics, science, history, theory of knowledge, computer science, technical writing. He has played leadership roles. He has presented at conferences. He's worked in IB schools all over in Thailand, in Mumbai, in UWC Pune, and now he, like I said, he heads KC High, a reputed school in Chennai. And what is common to all of them and me, what we share is a passion for math learning, math teaching, for passing on that joy one feels with math and thinking about it. So this is the general sort of a background. And okay, let's get started. So we came upon this topic, is math learning hard, based on all our and GenWise's experience with teaching children math, observing teachers, working with schools. And it seemed like a very a question that brings a lot of emotion to people. Either people love math and they fly with it, or they like, children don't like math and they struggle with it. Middle ground was not that populated. That's where we came to it. To start off, let me say that this, whether math learning is hard or not, is actually a subset of a larger question, which is the anxiety that surrounds math learning. So let's start there. And so this math anxiety, um, how does it happen? And what is the role? We are all part of it: parents, educators, teachers, curriculum makers, everybody. So let me start with Mick. Mick, as parents, who are members of a larger society, how do you see in your role as head of school and with your experience this notion of this math anxiety?
Thank you, Soumya. Am I audible? Can you hear me?
Yes, Mick.
Excuse me. Okay, good morning, everyone, and thanks for the introduction, Soumya. It's a big topic, mathematics education. Is mathematics learning difficult, and math anxiety? I do have just a few slides to kind of structure what I'm planning to say, because it's such a big topic and it's easy to go off on a tangent. So do you think I could just share my screen? Would that be okay with you?
Please do, please do.
Okay. Great. Are you seeing that now?
Yes, Mick, all good.
Okay, so well, first of all, I think it's important that if you're interested in the topic of math anxiety, that you understand it is an academic topic and there's a lot of research available. As a matter of fact, even the Wikipedia article, Mathematical Anxiety, is very well written, well constructed, and it has excellent references. And I should also add that just a little bit of research on the internet will give parents and others, teachers as well, a lot of practical advice and tips about how to remove math anxiety and how to help kids who are suffering from math anxiety. I think my point is going to be that a lot of this anxiety is actually adult generated, and that comes from both parents and from teachers. But first, let's just get an understanding of what math anxiety is. And of course, it's connected to fear. And kids are afraid of being humiliated. And I think that's really the essence of the problem. Because they're afraid of being humiliated, they get into this vicious cycle where they avoid answering questions, they avoid doing mathematics, they avoid speaking up, they avoid asking questions because they're afraid of the humiliation. Now, that avoidance, of course, then leads to poor performance, not understanding, poor performance on exams and tests, etc., which further feeds into the fear. So the question that we have to ask is, if we're going to try to break this cycle, where do we try to break it? And I think we have to understand that mathematics is a very emotional subject. And removing the fear, to me, is the most important part of breaking this cycle. Now, of course, it depends a lot on the child and what age the child is and the teacher and the situation, etc. But creating a more joyful environment in a mathematics classroom is absolutely one of the most important aspects of removing fear and removing math anxiety. And of course, any teacher of any subject, you can't tell a teacher of poetry, for example, that poetry isn't emotional. But there is research that shows that students have a very emotional reaction to mathematics. And if you think about it, from a young age, students are aware, children are aware from a very young age that mathematics is typically the subject in which you are judged as intelligent or not intelligent. And that is a huge emotional hammer. So we very much have to be sensitive to kids' emotions in a mathematics classroom. And as I've said already, try to create a more joyful, understanding, compassionate environment, and especially for those kids who struggle a little bit with mathematics. And sometimes mathematics teachers need some training in this because mathematics teachers themselves are typically kind of naturals at mathematics and they do not understand the emotions of the kids who struggle with it. So those are some important first steps. I think if you look more carefully at the causes of math anxiety, you're going to see two problems. One of them is this fixed mindset, and we have to challenge that and address that wherever we see it. This idea of I'm no good at maths, and that this is some kind of essential characteristic that's sort of hardwired into your DNA is something that we have to challenge and remove. And it's remarkably common in society. And then there are a lot of social pressures, and these social pressures often do come from parents. Parents often have a lot of anxiety about mathematics. They care a lot about the mathematics grades. The kids pick that up from an early age. One more factor that I don't think we spend enough time thinking about, but which parents might want to think about. If you look at 30 years ago, or even before that, when I was a kid, you would see that mathematics took up a significant chunk of the curriculum. But these days, everything has changed and the curriculum looks more like this. And we've added all these important things, you know, life skills, technology, citizenship, etc. And the mathematics slice of the pie has shrunk. And therefore, when parents are looking at what their children can do, they often see what they perceive as insufficient mathematics skills. So it's really important that parents are constantly constructive, loving, and creating that sort of joyful environment around learning mathematics. I would say that adult-generated anxiety is the biggest problem when we're talking about math anxiety. And we hear it all the time, and I'm sad to say I've heard it from teachers, I've heard it from principals, I've heard it from parents, etc. This attitude that I don't like maths or I was never any good at maths. I've heard a principal get up and say that in front of every kid in the school and expecting a little bit of giggle and approval for that. I like to say an educator who says I don't like maths is like a surgeon who says I don't like to wash my hands. Teaching mathematics to children, teaching numeracy, teaching these fundamental skills is part of our job. Whether you like it or not, we have to do it and try to do it the best we can. It's a critical part of our job. Numeracy, data sensitivity, understanding data, understanding numbers, communicating rationally, using logical analysis. These are all fundamental skills in any field. So we have to generate positive attitudes about mathematics. I think the last thing the last couple of points I'll make. One of the foundational problems is this lack of numeracy and lack of what the experts call number bonds. And that is, when we're young, we learn things like 7 times 8 equals 56. And it becomes so automatic, it's like a muscle memory. And we have to get that foundational numeracy in place in order for us to build upon that foundation later on. So oftentimes when I see in the preteen and teenage years, kids who are having difficulty with mathematics, 95% of the time, there's some problem there in terms of their foundational numeracy. And unfortunately, there's no way to fix that except to go back through the times tables, to go back through fractions, and to make sure kids have the foundational numeracy in place. So my advice to parents of young kids is, remember, if you're interested in your child doing well in mathematics, that slice of the pie is shrunk. So you have to give more time to it and make sure your child has foundational numeracy. Spend time with your child in a joyful, loving environment. Practice the timetables, ask them about percentages, talk to them about fractions, and make sure that the children get their foundational numeracy in place. I want to make sure that there's enough time for everybody to speak, so I'll probably just stop now. But I do have a few more things to say, which we may be able to get to in the next section.
Sure.
So I hope that was okay, and I'll look forward to some of your comments and questions after the other speakers.
Thanks, Mickey. I really loved that point about the slice of the pie shrinking. That is so true, actually. I mean, children are, are sort of facing so many more subjects now that math has sort of taken a smaller proportion. Yeah. Jayashree, we'll move to you. So yeah, maybe we can talk about, why is it so in math itself? What is so special about math as a discipline that this subject gives? Like, I've not really heard of history anxiety or geography anxiety. So what is it about math as a discipline that causes this? Go ahead, Jayashree.
Yeah, thanks, Soumya, and thanks, Mick, for naming the elephant in the room. Like saying that the belief that if you're good at math, you are intelligent. So that seems to be an unstated this thing which goes around. Like, now I'll come to what you asked, Soumya. What is it special about the discipline of maths? There are 2 things that I'd like to point out. One is that, like, when kids start learning maths, maths, it sort of comes up from your daily life experiences. You start counting things and you say that, okay, this collection is larger, this collection is smaller. And then as kids, we as parents introduce them to shapes, like, so they are familiar with these words, a triangle, a circle, a rectangle, and they have some sort of a mental image as to what these looks like. And then they move on. Very soon, maths sort of cuts its relation with the concrete and it moves out into the abstract. And the rules of the game sort of keeps changing in math. Like when you're first introduced to multiplication, you have this implicit this thing. Multiply means it becomes larger. So whether it is stated explicitly or not, many kids seem to have somehow formed the impression that multiplication is something that makes larger. And come fractions, they see that multiplying by a fraction makes smaller. So something which they are used to, which they have learned by observation, is no longer true. And as far as they are with recognizing shapes by what they look like, suddenly they encounter the small wedge-like shape which the maths teacher calls a triangle. Why? Because it has got 3 sides. So what you call as a triangle or not a triangle depends upon how you define what it is and not what it feels like. And similarly, like when you're looking in terms of numbers, counting, comparison, all those things you can verify. Like when you say 5 into 4 is 20, you know that 5 collections of 4 make 20. But then you say minus 5 into minus 4 is plus 20. How the hell does minus into minus become plus? Where does that come from? There is no real life thing which you can go to out there and verify. There are certain transition points that I would say where you used to a certain way of thinking because of the kind of life experiences that you have had. That works pretty well till a certain extent. And then when you move into higher math, these things you will have to go back and revise them. So what exactly is happening is that you started with numbers, which the first experience with numbers would be counting. Then you count and then you find that whole numbers are not enough. Then you bring in fractions. So far so good. Then uh, then then you extend it to negative integers. Negative integers, yes, you can say that it's temperature below zero and all that, but the analogy goes only thus far. The moment you start multiplication, when you can make children understand what negative integers are by saying that this is a temperature below zero, or this is so much below sea level compared to whatever. But then why do you multiply negative numbers? Multiplication of negative numbers is a purely abstract thing, which is a rule based idea. So this is something which children need to understand, and often gets missed out in schools. So that way, this no, building up based on internal coherence is like you define a raised to 1 and then you multiply it by a, you call that as a square. A multiplied 5 times is a power 5, and then you say that a power 0 is 1. Now why should a power 0 be 1? Why not 0? So a power 0, until and unless you define it as 1, the rest of the structure which you have built up is not going to hold. Therefore, you need to define a power 0 as 1 and not something else. So there are these finer aspects which come in as you move up in the ladder. And often children are not able to absorb this. So this is one aspect of the nature of maths, which sort of you have to keep revising what you know, going on to larger and larger sets. The other thing is like in any other discipline, like any discipline has got its own ways of thinking, which are very specific to that particular discipline. Like if you're looking at history, there is a certain set of questions which you ask and certain approach which you would take to solve the problem. You find a bone, and then like from there, how do you build up the story? Like, and then like if you have a historical narrative, how do you check whether it is true or not? So there are discipline specific ways of thinking for all disciplines. So if you look at that for math, it's like you start with a problem. So how do you approach a problem? When I talk about when you're solving a problem, I'm not talking about just the textbook problems. Like say I say that I have this block of cheese and I'm going to slice it 5 times. So how many pieces do you end up with? Now how do you start even like when a mathematician asks this sort of a question, the implied there is that it's not just about like if I slice it 5 times, how many pieces are going to get. The answer which you produce should be such that it lets you answer the same question for like if you're slicing it 10 times, how many? If you're slicing it 100 times, how many? So this generalization is something which is like the warp and weft in everything in maths. You need to be able to think of the general this thing. Now how do you approach this sort of a problem? There are specific ways, specific techniques which you can use, heuristics. So often these what we call as processes of math are not very much focused, and these are the core of the subject, I would say. The curriculum framework NCF 2005 talks about shifting the important from the content to the processes. So very often the processes of math. Now I didn't talk very much about the processes. Probably I'll come back to that. I wouldn't take much time right now. So this the point that I wanted to make is that each discipline has got its own set of processes which children need to be familiar with. Uh, Often it so happens that we don't spend enough time to familiarize students with the processes of math. Yeah.
Yeah, thanks, Jayashree. That was very illuminative. Especially, I like this idea of where you said no that we are broadening out continuously. And I remember that when I first met calculus in 11th grade, I was a bit stunned. I just didn't know what to make of it, and so my all my whole confidence in math sort of took a bit of a beating, and it took me a while to run with it. And I can't say I understood anything then, but I just learned to do what needed to be done, and the understanding came much later. But I guess if this happens in what Mick also called as the foundational math, then the child will just it'll just stall the whole learning process. Yeah. So this then logically brings us to the third part of the thing, which is the curriculum and the teachers and that role in this math anxiety. Sundaram, we can um, offer this to you, please.
Thanks, Soumya. The root causes of this whole problem is, I would say, two. One, which Jayashree has already pointed out, that math is a different kind of subject. What I would like to add is predominantly conceptual, mental objects. And the way this abstraction has to be taught has to be totally different. It cannot be a lecture method. It can't be a show and tell method. It has to be a method which makes you relate these concepts to what you see around you. So the whole pedagogy, I would say, the present pedagogy is very suitable for text-based subjects, English or social studies, a lot of, but that kind of pedagogy is not at all suitable for maths. A lot of activity is required, a lot of introspection is required. So children need more time, and the curriculum does not give this time. It is overloading primary school with all kinds of unnecessary things. So the time available in the class to enable, even if the teacher wants to, understanding of concepts is very, very lacking. And as to parents and teachers, they all have come through the same kind of math education in the last 2 generations. What else do you expect them? So this is a problem. So the fundamental thing is the curriculum has to be simplified, and it has to be taught in appropriate pedagogy of discussions, activities, and relating to your surroundings. This is easy up to class 8, as Jayashree said. Once you start with integers, things take a different shape. That's all I have.
Yeah, thank you, Sundaram. So then this takes us to the next step. So what can we do if these are the, if this is the story behind the part of the story behind the math anxiety? Then what could we do? Maybe we start back with Mick as a school head, and as for parents, what could we do? And then maybe Jayashree, you can go and say as a teacher what we could do. Yeah, Mick.
I think, well, what we can do depends on who we are and what problem we're trying to solve. So a parent, a teacher, a principal, the demographics, the particular kid, etc. All those are important factors. In terms of curriculum, I think Sundaram's already mentioned the most important parts, which is we definitely need to use more manipulatives, have more activities, make mathematics more joyful, and in particular, make sure that people who love the subject of mathematics are teaching mathematics, because that's, in the end, you have to have a happy, joyful classroom. I think we can also reconsider some of these high stakes mathematics assessments that are happening. And they're certainly happening in high school, but now they're happening, I mean, they're happening in middle school as well. And I think it's important to understand that not being good on an algebra test is not some sort of crippling condition that's going to uh, destroy somebody's life. Yet it's amazing how much parent anxiety and teacher anxiety we generate for kids who are not doing well on algebra tests. And I think if you look at the sort of Scandinavian model, where some kids choose mathematics around middle school and some kids do not, that it's worth investigating that. And it's worth thinking about from the ages of 12, 13, 14, we're going to see that some kids are not going to do very well on mathematics tests. Now, of course, it's important to have interventions and to try to help them, etc. But there should also be other pathways in the curriculum in high school for them. Just as, you know, as both Jayashree and Sundaram have pointed out, mathematics has its own way of thinking. It's a special type of subject, just the way the fine arts are. And we don't force every child to learn an instrument. So maybe we don't have to force every child to do abstract algebra and trigonometry and some of the areas in mathematics where they're struggling, particularly in this age where there's so much data and so many things that they can learn with numbers, with data, and with computers. So perhaps we can give them a pathway where every kid can be successful while still allowing those kids who are very excited about mathematics to accelerate themselves, to push themselves, to stretch themselves without beating down the kids for whom algebra is not that much fun.
Thanks, Mick. Yeah, Jayashree, please share your thoughts on this one.
Yeah, so I agree with what Mick said. It's not necessary that you stuff mathematics down everybody's throat, and there should be something in the math class which is accessible to every child, and at the same time, the ones who want to go more should be able to go ahead with it. Now, I want to go back to the cheese problem, which I said. I drew that from one of the like much watched videos by Polia, the master teacher. It's called Let's Teach Guessing. So in it, like he says, like, okay, if I have this block of cheese and I slice it 5 times, how many pieces am I going to get? How the hell do I approach the problem? So he starts with, okay, let me start with a line and I'm going to place points on it. So if I place 5 points, in how many different pieces is the line cut? And then you move to a plane and I'm going to draw 5 lines in the plane. How many is it? How many is it? How many parts is it going to be cut? Can you see some patterns? Now, if I have a block of cheese and I cut it into 2 pieces, like just 1 slice, how many? 2, how many? There are things which you can observe. So notice that from a problem which looked unapproachable, or like, when you say 5 cuts, how am I going to cut? Like what is a different, I could cut it straight vertical, I could cut a slant. How am I going to cut? So from a fairly loosely defined problem, invite students to ask for clarifications, simplify the problem, observe patterns, and then get them to guess. Now, this is not just wild guessing, this is an informed guess. So these are all like what I mentioned earlier, the processes of maths, like when you're faced with a problem, working with heuristics, simplifying the problem, looking at an analogical problem, like informed guessing, coming up with conjectures, and then moving on to justification and proof, whatever. But normally what happens is that we are so focused on the justification and proof part, the creative part that is involved in doing a problem often gets glossed over. So like if we are able to give students problem like this, where there is scope for creativity, some simple things like start with a domino, arrange dominoes into a rectangle. It comes to you that there is a fault line going through. Now then ask the question, can I arrange these dominoes in such a way that, I don't have a fault line? You struggle with it for some time. When I did this, I was quite surprised that the smallest rectangle that I can get is 6 by 5. Why is it not possible for a smaller dimension? What if it is a square? Can I make a 6 by 5 is possible? Can I add one more row or column and make it into a 6 by 6 square. It turns out it's not. The smallest thing which is possible is 8 by 8. So when you throw these kind of problems, which are what I would call the low ceiling, high threshold task, there is something in it for each child to feel happy about. Yes, I took a step. And at the same time, you're focusing on the processes. You're focusing on the kind of processes that a mathematician engages in when he makes his discoveries. So having a taste of that, like in my own these things, I have had children name whatever it is that they found. You know, they are proud of what they come up with themselves. This is Nishan's theorem, or this is Neha's rule, whatever. So the joy comes back into the math class. So I would say that giving children these kind of activities, yes, I realize that the curriculum is important and the exams are there, but giving a taste of what it is to build math, you know, with focus on what is special about the discipline. At least if they have a taste of what it means to do math, I think it will go a long way in addressing the anxiety. Yeah.
Great. Thanks, Yashri. Sundaram, please, would you like to share your thoughts on this one?
Yeah. When it comes to what educators can do, educators operate at three levels. There are educators who make policy. There are educators who manage institutions. There are educators who teach in the classroom. Now, so it has to start from the top. The educators who make policy need to think about math pedagogy and re-look at the curriculum. They also need to look at teacher training. Right now, the present kind of teacher training is not at all suitable for teaching concepts. It is for teaching a lot of facts. So that has to change. At the management level, unfortunately, many principals are non-math people. Okay, so they are not willing to touch math also. So it has to change at that level. Then only the teacher in the classroom has any kind of authority or ownership to make changes. Yes, the teacher can make a very small change within a class, but to make any major change, the top two layers have to work and change the things. That's the only way to solve the problem.
Thanks, Sundaram. Yeah, I have actually a couple of questions more to talk about, but I'm seeing that there are a few questions on the chat from the audience. Yeah, there's one question, I think, Jayashree, it goes a little bit with what you were talking about in terms of teaching a differentiated classroom. In a same class where some students are fluent and some are struggling, how do we approach their class? How to ensure the strugglers don't feel the pressure while the others don't get bored and impatient? I think this is an issue, and I think it has also been an issue, particularly this year with online. But yeah, I'll leave it to Jayashree to go ahead. Yeah.
Yeah. So one way I can think of is to have a differentiated task itself. Like when a teacher goes to this thing, like the teacher normally knows the pulse of the class. So set the task in such a way that there is something for everybody to, like do. Now, there are some aspects of the curriculum, like if you have to multiply polynomials, you have to multiply polynomials. There is no way about it. So in such situations, what I generally do is there are certain, it's not about what I generally do, it's more about what I avoid doing.
Okay.
So one thing is like, I post a problem on the board and then say, let me see who would get the answer first. So the moment I do that, there will be one child whose hand always goes up, and there will be the child who is struggling with it, who feels bad. So the time tests, like you give kids a bunch of 10 questions and say that answer this in 5 minutes flat. So give children the time and space for them to work at their own pace and this thing. And like Mick said, it's not necessary that everybody should reach the finish line. There may be kids who are able to do only so much and then stop with it, which is okay. So communicating that it is okay not to be able to multiply, like say 4,785 into 5,947. It's fine if you make that sort of a this thing. So so setting those boundaries and letting children know, make them feel accepted.
Hmm.
There is something which, like, if you listen carefully, there is something that every child would say.
Hmm. Hmm.
And another thing is, like, not being judgmental. The moment a child comes up with an answer, if you say that that's a wrong answer, that's it. The next time the child is not going to say, like, say, okay, this child says this, does anybody else have got anything to say? So when the peers come to, hey, this is not the way I think about it, this is the way I look at it, if you ensure that there is a discussion that happens in the class without me as a teacher, and as a grown up stepping in, I think that sort of uh, you know eases the thing a bit.
Yeah. Yes, Sundaram, please.
I would take Jayasree's example a little further. The teacher should teach less and allow children to learn more. And this is possible by activities, by individual assignments. So the teacher is more of a helper and facilitator than a lecturer at the end of the class. Of course, it's a much more complicated issue, but I'm saying at least the approach should be to allow children to explore and learn on their own, and teacher to help out as and when necessary.
Yeah, for sure. Yeah, so here's another question that pushes it a bit. It is, how can we convert abstractness to be relevant for students? So my quick response to that would be that it is not possible sometimes to make it relevant in the sense of being, something that you can see in real life or something that you can get your hands around physically. It is not. But before that stage is reached, the child should have had basic numeracy and basic mathematical foundations, like Mick mentioned, ensconced within him in a coherent, a solid and comfortable way, that he has the confidence and the emotional comfort to push to the abstract. This is what I would say. Mick, perhaps you can take this and have, maybe you have something else to say here. You're on mute, Mick.
Let me try to address both those questions in the same.
Sure.
So the first one was about differentiation. The second one was about abstract. So differentiation is one of those words like digraph that has a different meanings to mathematicians than it does to most of the world. So by differentiation, I mean differentiating the curriculum so that every kid in the class gets a good lesson. So in terms of differentiating the class, let me just ask you this one question and think about this for a second. In a mathematics classroom, what is the most valuable resource? In a mathematics classroom, what is the most valuable resource? The most valuable resource in a mathematics classroom is the teacher's time. But who demands most of the teacher's time? The kids, who are often products of their parents, who are typically enthusiastic about mathematics, the ones that are asking all the questions, the ones that are answering all the questions, are the ones who typically demand the most teacher's time. So I think one thing that a teacher needs to be aware of in a mathematics classroom is how is she using her time, or how is he using his time, and to make sure that the kids who are struggling with the topic are getting the lion's share of the teacher's time, because they're the ones that need the teacher's help. So that requires a very carefully planned lesson in which you have activities for the kids who can teach themselves and who are likely to benefit from research projects, etc., to go off and do some of their own things and to explore, and especially computers. And we haven't really talked so much about computers, but computers are an extraordinarily useful tool in learning mathematics. I do not know why we keep them out of the mathematics classroom. They can be useful for the advanced students who want to do research and who want to learn about graph theory, etc., but they can also be very useful for the for the students who need repetition and skill building. So I think a very carefully planned lesson where you as the teacher anticipate who needs what is really important in terms of differentiation, and that you dedicate a lot of your time to helping those kids who need a little bit of a nudge and need a little bit of encouragement during the lessons. And then I think, as Sonia's already said, you're going to help the children who need to understand abstraction through problems. You know, it can be how do we relate X and Y to things like the number of marbles and the size of the game, or whatever it is that you can find in, you know, the slices of cheese, or whatever practical things you can do to help them understand abstraction. If you're spending more of your time with the students who are going to need the help, then everybody in the class will actually benefit.
Thanks, Mick. Yeah, great. Yeah, I think there's one question on the chat. I can request people, if you, I'll read out this one, and at this, if you have something more, you can even unmute yourselves and ask, turn your videos on, it would be nice. So this question that's there right now, in the foundational years, building conceptual understanding is more important or logical thinking? What should be the ratio of teaching and learning? I think the ratio should always be rather low. I mean, the learning should always be primary with respect to the teaching, but go ahead. Jayashree, would you like to take this first? I mean, all of you can.
I would go for a more or less equal this thing of conceptual and logical thinking. I think Mrs. Sundaram would be in a better position to take that question.
I think both these are intertwined. You cannot teach abstraction without helping somebody to learn, think logically. Because abstraction is something which you form in your mind. It's not something you remember. And to form that in your mind, you got to have a logical way of thinking. And also, I would like to add on about abstraction. The human mind is actually built for abstraction by evolution. You see, all our social relations, they're all abstract. So actually memorizing huge amounts of data is very unnatural for human brain. So if you present an abstract idea, like even take simple idea like place value, with proper kind of materials, the child will just grasp it because its ability to, but a chimpanzee can never do it, but a human child can do it. So you need to present it with appropriate materials and events so that the child gets the idea, and it works in practice. It works very easily.
Mick, would you want to comment on this?
Yeah, I agree with Sundaram there. You know, when we're talking about logical thinking, conceptual thinking, abstraction, and skill building or numeracy, they're all intertwined. I mean, if you ask a 5-year-old to do skip counting, and a 5-year-old has to do 3, 6, 9, 12, 15, or even more challenging, you know, 1, 4, 7, 10, 13, 16, that's abstract. That's concept building. That's abstract to a 5-year-old, right? And then if you start at, you know, 22, 25, 28, 31, or you do skip counting by sevens, that becomes even more abstract and more conceptual. So the important thing is to have quality activities, and especially a really positive relationship between the child, the teacher, and the parent. And that this kind of environment supports children as they learn numeracy and conceptual thinking and abstract thinking and all of these things.
If there are more questions, please do feel free to unmute yourself, turn your video on if possible, and ask. Okay, I guess there's nothing at the moment. I have a question, which is that,
Sorry, Soumya, it's
yeah,
Ekta.
please.
I cannot turn my video. I'm so sorry about it.
No problem.
Um,
Ekta. Please carry on.
so yes, I am a math teacher. Um, what I wanted to know, I do, and this is my thought, and I wanted to know what we feel. As Mr. Sundaram said, that there are so many things we do in primary, and I am a primary teacher. Um, I feel, and now I'm going back to the days when we were taught. Yes, obviously the ways we're teaching were different, but I do feel that we were not taught so much. I really feel that now we are trying to put a lot of concepts in, in primary, like which we would have learned at when we were a little more older. And I also feel that has to do with our mental, like where we can understand abstract more, isn't it? So and here because obviously I'm teaching and we are trying to teach a lot of things. Okay, so what I mean, I wanted to know, so what is your what are your thoughts on it? Because now I understand, yes, fraction basic, fine. I'm just giving examples. We are trying to teach here the kids about some translation, and then move rotation, how an object will look, which we learned at a much higher grade, at a grade 4 level. And while I teach that, I really find it difficult, even though I get the mirror and everything, to teach, because it's very difficult for them to then, visualize.
So let me just try to understand the question, Ekta. Are you saying that the number of things we're teaching them are more?
Yes.
Okay.
Yes. I mean, we are trying to bring more and more, at a younger age. And I remember as a kid, I did not learn as much at a younger age. Eventually we learned everything, but yes. So if we were supposed to make some changes to the curriculum, what would, that is what I wanted to know.
That's always a delicious question to think about. So I'll let Mick go with that. Yeah, to start with, perhaps.
Yeah, so that's a good point, Ekta. And I think that pie chart that I showed earlier that had the whole curriculum, the mathematics pie slice gets thinner, but then we're trying to add so many new branches of mathematics. We're doing data handling and graph theory and all these things from a young age. So I think as a teacher, first of all, I know we're going to have a debate about this, but as a primary mathematics teacher, it sounds like you're teaching either first, second, or third grade. Your allies are your parents, and your parents, the parents of the children in your class, if they're happy with what you're teaching, then let me tell you, as a school principal, a good mathematics teacher is worth her weight in gold. And no principal is going to interfere with what you're doing if the kids are learning a lot and the parents are happy. And that's where that emphasis on numeracy really becomes important. And I know they're trying to bring in all these concepts and all this abstract thinking and all these word problems and all this data handling and all this stuff into primary mathematics. But you need to ask yourself, what do the kids really need to learn? And you better stay focused on numeracy. And if you do, I'm sure the parents will be happy. And if the parents are happy, the kids are happy, the parents are happy, you're going to be fine. And the kids will be better off later on in life because they have those foundational numeracy skills.
I think that's key. Yeah.
Yes. Thank you. Yeah.
Soumya, Shashidhar here. Can I?
Yeah, please, Shashidhar.
Yeah. This is regarding this point, also the earlier point which is mentioned, where they told, right, like some classes, some students can learn fast, other students cannot learn fast because of whatever reasons. So one of my thought is, like, unlike other subjects, like your English, sociology, social studies, and other subjects, where even if a student does not learn a particular concept, he can always cover up later and it does not affect his building further skills. Whereas according to me, based on experience, I'm not an expert in maths teaching, but more from the experience. Like maths is basically, if I can use the word like serial, like I have to put a step and then continue. Like I can't go to the third floor without building the first floor. Okay, it is that dependent. So one of the things that is happening in current way of classroom teaching for mathematics is for justifiable limitation, because the teacher has 45 minutes, 1 hour, they can't teach everybody. There's a limitation. But what is happening is 50% or 20% of the students who do not understand those concepts. And because of the content, more content is being pumped upon, like I thought told, they don't have opportunity to learn that again. So they have to go to the next topic, next topic, next topic. And over a period of time, this multiplies. And by the time they come to the like 7th, 8th, or 9th, 10th, they suddenly feel like mathematics is not a subject they can relate, although they're intelligent. This is what Salman Khan of this Khan Academy calls the Swiss cheese. From outside, it looks like a box, but inside we have a lot of holes. So I think the way mathematics has to be taught has to be completely different when compared to other subjects. So one solution, because I keep visiting these education institutes who experiment. I happened to visit one Vande Mataram Research Foundation, like in Telangana, Andhra, where a retired teacher has actually experimenting it. He basically says like it has to be like he is using a tool of peer learning to address this. Where in a, like I don't have to teach like in a broadcast mode, because in 50 minutes putting everybody the same pedestal, we have to grade students at whatever level of their teaching. So we have to go in that grade. So that is one basically serious thing which you have to consider pedagogy for mathematics. Otherwise, whatever the research, the abstract we do, but if the delivery is going to be in the same standard, we're not going to solve this problem for mathematication. Or my thoughts. I am happy to hear from the experts. Thanks so much for time.
Yeah, thank you, Mr. Kanakiri. Yeah. Would any of you like to share your thoughts on that? I think this is exactly what Jayashree also was talking about, differentiated learning, and what Mick was also saying about, in fact, even focusing on the topics that relate to basic numeracy rather than the fancy ones that have got it added on now. Yeah. Would you like to respond to it, Jayashree or Mick or Sundaram, please?
I would like to add here
Please.
that at least in the private schools, there is a lot of flexibility available until class 8, and which most schools do not use. So that's why what Ekta was saying, actually it is possible for a private school principal, if she has the thinking and ability to convince parents, to reduce the curriculum in primary and speed up the curriculum in 6 and 7. It's like a car. You don't start at 30 kilometers per hour. You start at 5 kilometers per hour and then accelerate to 30 or 40. So we are trying to unnecessarily accelerate in the wrong idea of the educators at the policy level that improving the curriculum means stuffing more. It's a wrong idea, but who will tell them? So it's possible, but it is a lot of work. You need to carry parents along, which is not at all an easy thing.
Yeah, thank you, Sundaram. Yeah. Do either of you have anything to share, Jayashree or Mick?
Jayashree, do you want to say something?
Yeah, I perfectly agree with the way Shashidhar sort of talked about the nature of math, where it's sort of one concept builds on another, and if you're left behind, you're left behind. And also about the about using peer learning to address these issues. There also I agree. In fact, I just wanted to add that that's also a way of differentiation, in the sense like, you know, the kids who always put up their hands, like when you put them in a group and make them in charge of explaining things to someone, they also gain by the process of explaining, and they don't like sort of demand more of the teacher's time because they are otherwise constructively occupied. So that's a good, very good strategy to differentiate instruction as well. Yeah.
Yes,
And
I think
also,
peer learning has a lot of
sorry.
potential, and group work, and in this case, um, helping the kids who already understand a concept through explaining it to others. I think we have to be a little bit careful here, because it is true that kids are particularly good at explaining these concepts to other kids, and they can use the same kind of language and they understand the kids as well. I do think we have to be cautious that we're not forcing kids who are quote unquote good at mathematics, or who are the ones to be the helpers or the explainers, to do this over and over again to the point where they're bored of it. Now, you do learn mathematics through teaching it. And I often say I never really understood these concepts until I had to explain them and teach them. So I think it's important when we're asking children to break into groups that we're sensitive to exactly what roles we're assigning to kids, and to make sure that the kids we're asking to take on these responsibilities are up for it. And there are many kids who really love to do this, and they do a fantastic job of it. But in mathematics, you do have some kids that don't enjoy teaching it to others. And some of those are very bright kids who love mathematics. And I think you need to build into your plans some avenues for those kids to explore on their own.
Yeah, I think I completely agree with that point of view also, which is that there are some children who find it a struggle to work with other children who are not at their level, and that's not. It requires a little more maturity of a certain kind, which they don't yet have, perhaps. But they fly with their math, and sometimes they get a bit dampened if they're asked to engage, and that sort of turns them off a bit, which also one needs to sort of be cautious about. But as Mick said, there are some children who love it and who really flourish if you put them in the role of a teaching assistant, so to speak, and great. So yeah, so I think that nuanced handling is critical, especially so for math. I just have one question which I must ask before we sort of wind up, even though we're actually over time, which is I was watching this Dan Finkel's TED talk on extraordinary math teaching. And so one of the things he mentions there about teaching math, one principle he calls it, is play. And I think we've all sort of touched upon it peripherally. But I'd really like to sort of nail that down properly before we close. What is the role of play in math education? Yeah, Jayashree, you can go ahead since I know you uh, resonate so much with it. Yeah.
Yeah, some of the things which I was saying, like when, let me say, what does play mean to me? When you say play, there is no exam at the end of the thing, and there is no judgment. So the moment you take that out, you're doing it for the joy of whatever it is that you're doing. So that takes away the it's not some kind of drudgery, and you're doing it because you want to do it. So setting up things in such a way that it passes on as play, and puzzles, like, we all would solve sudoku. It's a game sort of thing. Like, ask questions there, like, will that grid which appears in the newspaper always have a solution? Will it have only one solution? How many numbers should be given so that you are able to find a unique solution? So these are all deep mathematics questions. So even from things like small games, puzzles, when and often when you are engaging with this sort of play, the questions come to you by themselves. So it's not something which is written in the textbook as an exercise which you have to solve, but it is a question which is your own question, and therefore you're driven to find the answer. And because there is no stick and no this thing, saying that you have
Correct.
to find the solution, you have to get 100 on 100, it goes. So I think that's the best way to do math. Yeah.
Thanks, Jayashree. Yeah, Mick, please, I can see uh, you're on mute, Mick.
Of course, play is extremely important. I'm not going to spend too much time talking about it. All mathematicians love to play. That's essentially what mathematics is to mathematicians. I remember, yeah, play is extremely important. Let me add one more thing. I remember reading a book by Keith Devlin many years ago where they did some research on how mathematicians um, view numbers. And mathematicians seem to think that numbers have their own personalities. So these little jokes and wordplay are extremely important for teaching mathematics to young children. Things like, you know, why is 6 afraid of 7? Because 7, 8, 9. And those kind of jokes and making numbers develop their own personalities are really important when we're teaching mathematics to young children. There are many good reasons for that in the literature. I won't go into it too technically, but yes, please play, have fun with mathematics, make jokes, and make it come alive in the classroom.
Thanks, Mick. Thank you. Would
Yes,
any,
ma'am, myself, I'm Damayanti Mathuri from Walistas International School, Bangalore.
yes, Damayanti.
I just have a small question. So actually, we are working with Cambridge curriculum. So we have a lot of methodologies and a lot of strategies to work on simple addition, subtraction, multiplication, and division to teach to the primary students. So I don't know whether the children are capable to take all the methodologies and can apply everything. So we can stick to only one methodology or one strategy to teach them, or like these all methodologies, whether they'll confuse and which one they'll apply. Also, I mean, like we cannot able to figure out. So what will be what we have to follow?
Would any of you like to take it? If I can. Yes, Sundaram, please.
See, basically addition means putting it together.
Yes, sir, all together.
Put together few things or a bulk of things. So once that understanding develops, you start understanding why certain processes followed. So they're not different methods. They're all because of the situation. Like for example, if you're adding, if the answer comes more than 10 because of the place value, you got to shift one of the digits. So this is not a rule. The problem is to make it a rule. If they can see with themselves what happens when they actually add 15 and 16 in terms of bundles and sticks, they will realize the rule. So a rule is very dangerous. A rule you can slip on the rule, but your basic understanding you will not slip. So I think we need to first show them what exactly is happening and then arrive at the rule.
Okay, so it's okay to
Ever,
teach all methodologies to the children, or only?
No, I'm saying there is no need to go right in the beginning to method. They themselves will figure out various ways.
Okay, okay,
But you need to present it to them in concrete manner
okay.
and different way. Like for example, they're adding 5 and 5 pebbles and 3 pebbles, it is 8 pebbles. But if you're adding 15 pebbles and 8 pebbles, it is 23. So the 2 has to go. No, they start seeing the logic. They need to understand place value and a concrete understanding of what is addition. So if these things are there, I mean, I can share you with you many files, etc. Please.
Yeah,
The
I think
point is,
I
we
think
should
we've
not go to rules without understanding what exactly is happening. That's all.
Yeah, Mick, please go
and
ahead. Yeah.
never forget the importance of that word why and getting the children themselves to compare the different methods and to be able to explain why they chose one method
Yes.
over the other. So when I'm trying to teach mathematics, for example, with a 15-year-old the other day, I was trying to teach elimination and substitution. Instead of telling him do it this way or do that way, I would ask him, which way do you want to do it? And why did you do it that way? And could you do it another way? And those types of questions can be very helpful when you're teaching different methods, and especially at helping children understand the conceptual underpinnings of the problem.
Thanks, Mick.
So thank you so much.
Yeah, sure, Jamin. Yeah, please. There's also a message on the chat, Damayanti. There is a blog that you could read. Yeah, go ahead, Vishnu. I see you're here.
Yeah, I'm sorry. I think time also is running out. So I'll make a very quick announcement and then we can wrap up. I know that there are many educators and principals on this group, and I'm sure they have a lot to say, but we may have to leave it for another day. Quickly, there are various upcoming courses, most of them online. There may also be a residential summer program, but we don't know what's happening with the second wave and so on. So please go to genwise.in. Particularly, I want to point out a few math courses which Soumya, Sundaram, and some others in the team have designed. And the whole idea is to sort of do what we've been saying in this Adda. And if some of you math teachers out there would like to teach some of these courses or hang around to see what the approach which is taken, we are very happy to give you the chance. So maybe some of the specifics of the approaches we are trying will get familiar with, and of course you might have good ideas for us. There are also some very interesting courses on parenting by Dr. Bhushan Shukla, who's a fantastic parenting consultant. He's a psychiatrist by profession, but he's a very wise person and combines expertise with practical tips. For other details, go to genwise.in. So we're going to wrap up here, and maybe each expert on the panel can just take half a minute to share some final suggestions.
Go ahead, Sundaram. You can.
I would say math is easy, but it is made difficult because the way it is taught. And because of so much of other structures like curriculum and things, examination is another horrible thing in primary school because it wastes so much of learning time. That's a problem. Okay. Otherwise, I think it is not easy to change, but it can be changed.
Thank you. Yeah. Jayashree, go ahead.
I would say that if children don't love maths, give them the math they love. There is a lot out there. Yeah.
Lovely. Mick, are you there? Yeah.
Yeah, I would say learning is hard. And it doesn't matter if you're learning chess or learning tennis or learning mathematics. Learning requires deliberate practice. That means you have to practice a lot and you have to know why you're practicing, how you're practicing, and how your practice is suited to your own learning needs.
Thank you. I think those are pearls of wisdom. So thank you so much, Sundaram, Jayashree, and Mick. And thank you all to all of you who have joined on this Saturday morning. I have enjoyed this as thoroughly as I thought I would, and perhaps more.